So I have a sequence 10, then I'm going to go 7, then I'm going to go 4, then I'm going to go 1, dot, dot, dot. So the first thing, and the question is find Tn, right? So the question is find Tn. So you look at your sequence, right? How do I go from 10 to 7? Minus 3. How do I go from 7 to 4? Minus 3. And you keep going, minus 3. Okay, so that gives me the first bit of Tn. So what's the first bit of Tn? It's minus 3n. Okay, so then it could be plus or minus a number. We have to try and figure it out. Okay, so Tn, so you use T1. So what's term number 1? What is term number 1? What's the answer? 10. So I should come out with a 10. Agreed? Right, okay, so I put in 1 for n because it's term number 1. So minus 3. So how do I go from minus 3 by 1 is minus 3, isn't it? So how do I go from minus 3 up to 10? Plus 13, would it be? Yeah, so plus 13. No, it's not plus 7, because minus 3 plus 7 would be 4. Yeah, I want to end up at 10, so I'm at minus 3, so I have to go up 13 steps to get to 10. Okay, right, check my answer. When term, so Tn, I think, is minus 3n plus 13. Okay, check my answer, put in n is 2. So minus 3 times 2 is minus 6. Minus 6 plus 13 is 7. Right? Yes.
Where did you get the 10 from?
Look, term number 1 is 10. Okay, so I know what term number 1 is because they gave me the sequence. Okay, right? Will I go again? Another one? Right. Example 3. Right, okay, so I'll do 1, 6, 11, 16, dot, dot, dot. Right, and the question is find Tn. So Tn, girls, you look and you say, how do I go from 1 to 6? Add 5. Then this would be add 5. And of course it has to be add 5 because it wouldn't be a linear sequence if you weren't always adding 5. So the first bit of Tn is what? 5n. Right? First bit of Tn is 5n plus or minus a number. Okay? So you don't know which number, but you use term number 1. So what's the answer to term number 1? What is term number 1? 1. Look at it. It's right there. Term number 1 is a 1. So when you put in 1 for n, because it's term number 1, and then you go plus or minus a number, you end up at 1. So 5 times 1 is 5. How do I go from 5 to 1? Minus 4. So my Tn is most likely 5n minus 4. Isn't that right? Check it out. Term number 2. 5 times 2 is 10. Take away 4 would be 6. 5 times 3 is 15. Take away 4 would be 11. So I'm right. Okay? So these are good because you know you're right. Don't you? Right. Got it?
Yeah.
Right. Can I move on to the other thing I wanted to revise with you? Right. Okay? So I wanted to revise with you. What are the natural numbers? What are the integers? What are integers? What are real rational numbers? And if they're not rational, what's the opposite to rational? They have to be irrational. So they can't be both. Would you agree? They have to be one or the other. Would you agree? Irrational numbers. Yeah, we've come across it lots of times. Don't ask me that because I get insulted. Right, okay, I get really insulted when people ask me, did we do this? And I gave 3 weeks trying to flog it into you. Right, okay, right. Natural numbers. Now, remember, maths people don't like writing out words. So what would natural numbers, what's the symbol for natural numbers? N, right? What's the symbol for integers? No. Z. They mess with your head, don't they? Right, Z, right? Integers are Z, right? Do you know what the symbol for rational numbers is? It's Q, okay? Right, and the symbol for real numbers, that's okay. You can guess that one. R. Right, okay? Irrational numbers doesn't have a letter, okay? So natural numbers N, integers Z, rational numbers Q, real numbers R. Right, okay. Natural numbers, tell me what natural numbers are. Positive whole numbers. So no negative numbers, no fractions, no decimals, right? Only positive whole numbers. So positive whole numbers. Give me an example. Positive whole numbers. So, yeah, we start at 1, 2, 3, 4. Is not a natural number? No. Right, the natural numbers, girls, are sometimes called counting numbers, aren't they? So you'd never start counting at 0, so you wouldn't? Right, okay, so if I started at 0, I'd be basically saying Fariha doesn't count, isn't that right? So I always start counting at 1. 1, 2, 3, 4, isn't that right? Okay, so the natural numbers, they sometimes call them the counting numbers. Okay, positive whole numbers. Do we remember what they are? Right, integers. What are integers? Positive and negative whole numbers. Right, so positive and negative whole numbers again. Still no fractions, no decimals. Right, so still no fractions, no decimals, etc. Okay, is 0 an integer? Yeah, it is. So the integers go not all the natural numbers, 2, 3, 4, 5, dot, 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 goes forever. But it also goes the other way, doesn't it? -1, -2, -3, dot, 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 -4, -5, -6, etc. Are we okay with integers? Right. Q is rational numbers. Does anyone remember what rational numbers are? They can be written as a fraction. So rational numbers are numbers that I might get a new board for this. It's getting a bit squashed here. Is it okay if I do rational and irrational, right, on this board? So rational and irrational, right, are the opposite of each other. So a number can't be both. Sure it can't? Right. Rational can be written as a fraction. Which is most numbers, girls. Nearly every number can be written as a fraction. So it can be positive and negative. Positive, negative doesn't count. Right, it can be both positive and negative as long as it can be written as a fraction. Irrational cannot be written as a fraction. So cannot be written as a fraction means it's a decimal that goes forever. I should have said a non-recurring decimal that goes forever, as in 1.333333 can be written as a fraction, but 1.715317941, one that there's no pattern. Is that okay? If there's a pattern, it can be written as a fraction, but if there's no pattern, it's just random numbers going on forever, it can't be written as a fraction. For example, rational number, right? A half. A rational number? Yeah? Give me another example. A quarter. 3/4. I make it -3/4 just to be. What about minus 2? Can that be written as a fraction? Yeah, it can. All I have to do is stick it over 1. Now it's a fraction, isn't it? Okay. Can 3 be written as a fraction? Yeah. All I have to do is stick it over 1. Now it's a fraction. Okay. Right. And so on. Right. Okay. Right. most numbers are rational, right? The majority of numbers are rational. There's a few irrational, right? So the irrational numbers are decimals that go on forever with no pattern, right? For example, you know the number pi. Do you know the number pi? It's 3.141 whatever, and it goes on forever. And if you have a calculator that shows 10 places of decimals, there'll be 10 different numbers after the decimal point. If it shows 20 places of decimals, there's 20 places of decimals. It goes on forever. There's no end to how many decimal places there are in pi. Is that okay? Right. Something like the square root of 2. Square root of 2 is a big long decimal that goes on forever. Okay, if you put it into a calculator, you put square root of 2 equals, and you press S to D, and you get a big long decimal that there's no pattern in. Right? Okay. What about the square root of 9? Is that irrational? No. What is the square root of 9? 3. So is that wrong? Yeah, because square root of 9 is 3, isn't it? And 3 can be written as 3 over 1. Would you agree? Okay. Can anyone give me another irrational number? The square root of 7. Not 7, because 7 can be written as 7 over 1, can't it? But the square root of 7, it's not a whole number. It's a big long decimal that goes forever. Is that right? Okay. Do we know the difference between rational and irrational? Yeah. Right. Okay. And then the next thing is a real number. Okay. So a real number, everything's real. Right. Okay. So real numbers are, right, everything is real. So it doesn't matter if it's a decimal that goes forever or if it's a positive whole number, they're all real. Okay, so everything is real. So the square root of 2 is real. A half is real. 1 on the other page, 1 is real. Pi is real. Right? Every number, every single number, right, is real. Okay? Right. Okay, so can I just do this with you? Right? Okay. So, if it's a natural number, you tick this. If it's a Z, you tick this. If it's Q, you tick this. Now, what they call irrational is everything less Q. That's what they call it, but they'll spell it out as irrational. Okay, so that's irrational. They'll tell you. Okay, right, and real. Okay, so if I have the number 3, right, is the number 3 a natural number? Yeah. Is it an integer? Yeah, because it's a positive whole number. Positive and negative whole numbers are integers, aren't they? Can it be written as a fraction? Yeah. Right, so if it's can be written as a fraction, it can't be irrational. It can't be both. I'd never take these two columns, sure I wouldn't. Is it a real number? Yeah, everything is real. Okay. What about -7? Is it a natural number? No. Is it an integer? Can it be written as a fraction? Yeah. So therefore it can't be irrational. And is it real? Yeah, because absolutely everything is real. Right? Okay, what about -2/3? Is it a natural number? No. Is it an integer? No. That's positive and negative whole numbers, so that's not a whole number. Is it can it be written as a fraction? Yeah, God, yeah. So therefore it can't be irrational. Is it real? Yeah, because everything is real. Okay, is that right? What about the square root of 5? Is it a natural number? No, it's a big long decimal. Is it a square root of 5? No. Can it be written as a fraction? No, because it's a big long decimal. So if it's not written as a fraction, it has to be irrational, isn't that right? It's always either one or the other here. And real? Yeah, every single thing is real. Okay, one more. What'll I do? Pi. Is pi a whole number? No. Is it a integer? Can it be written as a fraction? No. So therefore it has to be irrational because it's either one or the other. And is it real? Everything is real. Right, have I revised natural, integers, rational, irrational, real? Right, okay. Time check. 27. I have until 45. I've loads of time. Right, okay. Can I revise coordinate geometry of the line with you? Okay, so coordinate geometry of the line, right, was, remember your points, and you graph your points. So we have a unit, so we have 1, 2, 3, 4, -1, -2, -3. I'll go 1, 2, 3, and I'll go -1, -2, -3. If I said plot the point 2, 1, this is the x-axis, this is the y-axis, this is the x-coordinate, this is the y-coordinate. Can we all plot 2, 1? What do? Start here, go across to 2 and go up to 1. There you go, 2, 1. Right? What about -1, -3? So what do I go across to? Always start in the middle, across to -1, down to -3. We okay with that? What would the coordinates of this point be? 0, 0. What's the coordinates at this point?
0, 4.
No, it's not 0, 4. It's 4, 0. Because you go across to 4, you always have to go across first, and you go up 0. What about this one? 0 minus 3, isn't it? Is that right? Yeah. Okay, then there was a couple of formulas that we had to know how to use. They're in the log tables. Bring your own log tables to the exam. They won't be given out to you. Okay, do you have these? Yeah. If you don't, I sell them for €4. I don't sell them for €4. Laurel Hill sells them for €4, but they happen to be with me. Right? Is that okay? Yeah. Right, because they're €4 in a shop, so we thought we'd order a few so we could sell them to you. Right? Okay? Save you going to a shop. Okay? So you go to coordinate geometry. Okay, it's on page 18. Off you go to page 18. When you get to page 18, there is there is formulas here on page 18. I'll blow it up here. So you need to know about the first 4 formulas. So you need to know about the slope of the line. There's a formula. You need to know about the length of the line. There's the formula. You need to know how to get the midpoint of a line, right? Okay, and you need to know how to get the equation of a line, and it comes in 2 forms. I'll deal with that in a minute. Okay, is that right? Vague recollection? Yeah, we did it this year, I think. Yeah, we did it this year, didn't we? So there should be a vague recollection. Right, okay. Right, okay, so if I said, here's my 2 points. Look, here's 2 points. Right, zoom out, I can. Thank you, because I would have forgotten. So here's 2 points, 2, 1, and -1, -3. And the question is, find the slope. Find the slope of the line that joins these 2 points. So step 1, what do? What do I call this point? X1, Y1, and what do I call this? X2, Y2. Okay, it's great, you remember something. Off you go to the log tables then, and you write down your formula. So you absolutely need your log tables. The area and volume formulas are at the start of it too, so you need those as well. Okay, so you absolutely need log tables. Okay, so don't wait until Tuesday morning, right? Okay, because I could run out, right? Okay, and don't come crying to me, I forgot my log tables, okay? Do you all hear me? Today is only Tuesday, so you don't have, today's Wednesday, you nearly have a week until next Tuesday, so surely someone will be passing a shop, right? And if they're not, €4 to me, and I'll sell you a set. Okay? Is that all right? Yeah. please don't not bring them. Okay, fill in your formula. Y2, what's Y2? Minus 3. Then it's minus, there's a minus sign. Then Y1, 1, all over X2, minus 1. Then it's a minus sign. X1, 2. Into the calculator with that and press equals, and you get minus 4 over minus 3, and the calculator will spit out a minus over a minus is a plus, so 4 over 3. That's your answer. Leave it as a top heavy fraction. Okay, is that right? Yeah. Okay, distance, same 2 points, right? Okay, if I asked you for the distance between the 2 points, the formula is actually called length in the log tables. Okay, length or distance. Okay, they call it length in the log tables, but the length and the distance are the same thing, aren't they? Right, just so you know. Right, so off you go to your log tables, you get your formula, which is x2 minus x1 2b squared plus y2 minus y1 2b squared. Now it looks very complicated, girls, but calculator, everything goes into the calculator, and it's easy enough. Same first step, x1, y1, x2, y2, right? Fill in. X2 is minus 1, minus x1, which is 2, all to be squared, plus y2 is minus 3, minus y1, which is 1, all to be squared. Then you type that as you see it into the calculator and press equals. Okay, the first thing you do is type the square root sign, and then you put bracket minus 1, minus 2, squared, etc. Exactly as you see it. Square root button first, because you can't put it in at the end. Is that alright? Are we all good? Right, into the calculator with that, and that will be 9 plus 16, which is the square root of 25, which is 5. Okay, that one actually turns out to be 5. Sometimes the answer might turn out to be the square root of 13 or something like that. Leave it like that, don't turn it into a decimal. Okay. Your hair is lovely. Will you stop brushing your hair inside my class, please? Right, okay. Now, next one, midpoint. Now, midpoint is exactly what it says on the tin, right? It's the point that's halfway. So your answer is going to be a point. So 2, 1 is there, minus 1, 3. So your answer is going to be in here somewhere. It's going to be halfway, isn't it? Right, okay. And your answer is going to be a point. So this one is slightly different in that you can't put the whole lot into your calculator at the same time, because there's a big comma in the middle of it, because your answer is a point. Is that okay? So same points again. So x1 is, right, okay, if I go like, sorry, x1 is 2, then it's plus x2 is minus 1, right, all over 2. Does everyone see how I ended up with a plus minus? Yeah. The plus came from the formula, the minus is part of x2. And a plus and a minus will give you a... Sorry. Right, is that okay? So plus minus, a plus and a minus will give you a... Just don't speak. A plus and a minus will give you a... It's on the wall. Minus, it's not on the wall in room 16, so learn it. Okay, right? And y1 is 1, and then it's plus y2, which is minus 3 all over 2. Plus minus will give me a... Minus, right? Okay, now you can't put all of this into the calculator together because you can't put a minus in, right? So what you do is you put this first term in, you type the fraction button first, and you write 2 minus 1 on top and 2 on the bottom, and your answer will be a half, right? Here you cancel, start fraction button again. 1 minus 3 divided by 2 is minus 1. And there's the midpoint, the point that's halfway. Are we good with that? Okay, right. And the last one is the equation of a line. So the equation of a line is, the formula is y minus y1 equals m into x minus x1. Now, this is one is different. All the other formulas, you need 2 points to fill it out. What do you need in this one? You need x1, y1, so you need 1 point, and you need, what does m stand for? No. Slope. M stands for the slope. Okay? Now, everyone will think it stands for the midpoint, but it doesn't. It stands for the slope. Have we all got that? M stands for the slope. So if I use the line I had there, I think we calculated the slope of it to be, I rubbed it out, 4 over 3. Right? Okay, so the slope was 4 over 3. And I gave you 2 points. Use any one of them. Right? It doesn't matter which one you use, because you will get the same answer. So I'm going to use 2, 1, because the other one had minus signs in it and they'll mess me up. Okay? Right, but if you use the other one, you will get the exact same answer. So you call this x1, y1. Remember, this one, you never fill in for x and y. So you just fill in for y1 and for x1. So it's y minus 1 equals m is 4 over 3 into x minus 2. Is that okay? Do you remember this? So you don't fill in for x and y, you fill in for x1, y1, and you fill in for m, right? Okay? So does anyone remember how to simplify this? You take the 3 and you put it up top over here, isn't it? Right, and you leave the 4 over this side. Is that okay? And then you multiply out. 3y minus 3 equals 4x minus 8. Is that okay? And then we normally have it x term, y term, number equals 0. So here's the wall. Bring the 4x over, becomes a minus 4x. Then you have plus 3y. Then you have a minus 3 here already. The minus 8 goes over the wall and becomes a plus 8, doesn't it? Equals 0. So we end up with minus 4x plus 3y plus 5 equals 0. Is that okay? Vague recollection? More than a vague recollection? Please say yes. Make me feel good. Right, okay. Right. So whatever crops up anyway, girls, don't leave blanks. Throw something down. Okay? So I've only about 2 minutes left, so I think I'm done. Okay? So throw something down. Make sure you have your log tables. Make sure you look at those constructions. You know the 2 constructions I put up? Right? Remember, one of those is coming up. Right? So if you haven't looked at them yet, they're on Teams. Learn how to do both of them. So don't come without your math set. So for your maths exam, you need to bring this, you need to bring your math set, and you need to bring your calculator. Do not come without a calculator, right? Okay, maths, log tables, math set, calculator. 3 things for your maths exam. Yeah, your math set, yeah. You need your compass and your protractor, yeah. And clean your tables, please.